Make sure everybody, has the clicker working and everything like that. Looks like we're good. Our first presenter is going to be Xiaohui. I believe we're live on the platform, so please welcome up Xiaohui for the first presentation.
Okay, so how do I?
You just yep, just clip that on yourself.
Oops. Oh no, go this way. Go this way. Good. All right. Thank you. Hey, everyone. Super excited to be here and glad all of you guys come here today during this, let's say, a little bit of a special weekend to say. I planned this about,
it looks like it's cutting now. Let me zoom out.
Oh,
yes. Is it cutting?
Yeah, a little bit, yeah.
There we go.
All right, thanks. All right, GM, everybody's good?
Yeah.
Cool. Yeah, according to Twitter, this should have already been canceled, so I'm glad you guys have made it out here. So in case you need some therapy, there's a corner over there. So we have the in-house therapist. If you actually need help, just go seek help. There's no embarrassment. Okay. Thanks all for coming. I know it's some interesting time to be here, and I planned this like half a year ago, and let's say this week there's some events happening, and I'm glad all you guys still come out here, and we're here for the tech. So if you're already here, you guys are the real big ones, I would say. Congrats. All right, thanks for all coming. So, here we talk about the technology, and regardless of, I heard there's some lord, in 10,000 miles from here, he made some decisions or may not yet. So if you're, upset or, depressed, always seek help. So, but here we are moving on. We are always building all the time, so we are here for the tech in the literal sense. And this event, we mostly try to, gather all the builders, innovators, entrepreneurs, or you are just casual observers, all welcome. Even if you are not in Bitcoin SV, BTC or BCH or whatnot, Dogecoin, just all welcome. Check out our hackathon. We just want here to build apps that normal average Joe can use. So, to me, that's the number one thing. We care about some legal part of things or social media things, but at the end of the day, I think we still mostly care about, all the apps. So for people who just new to this hotel, if you're in the lobby, there's a big plate over there, there's some history. So basically, after World War II, a lot of nations, representatives, they gather here, right here, in this hotel. The draft of the United Nations, charter right here in this hotel. So I kind of feel, we are, kind of in the history. This is a monumental event. So, just connect with people, take a lot of pictures and videos. Hey, you don't know, maybe some years later, there's a new plate out there saying, hey, this group of people, come here to save Bitcoin. Okay. Thank you. So we talk about, apps, So this is 15 years since the Bitcoin launch, right? we always talk, hey, Bitcoin is such a fascinating technology. It's a groundbreaking. It's going to revolutionize, I don't know, supply chain, timestamping, e-commerce, real estate, derivatives market. But hey, 15 years, how many people use Bitcoin today? Okay, that's good. Okay. How are you using it?
Peer-to-peer cash.
Okay. What app do you use? Okay. Yeah, we have, let's say some primitive apps, right? But, there's no, let's say, mainstream app as far as I can tell. Because I walk outside this street or go to any website, if I want to use it, it's just simply, it's not there yet, okay? So when we are here, we try to, create tools or exchange idea. What is actually the killer app going to be? To be honest, I don't know. Probably Satoshi doesn't know either. Otherwise, he probably have told us, we can just build it. So, we are in this space and people saying we are pretty centralized, but, that's actually very far from from what I can tell. It's pretty much decentralized. I kind of see, when people build apps, I could see, there's two general philosophies approach this. One is some people call it boomer, maybe put a quote around that. Or another group called almost like, degen, but not in the coming your farm, tongue in the cheek way. We talk about, lock-up coins, inscribe first and chill later. We have OG, we have all kinds of memes. That's one type of thing. It's kind of like a grassroots. People wearing T-shirts, and you just have fun. And a lot of times you don't know why you are even building this, or you are pumping some memes, or you are, let's say, minting some bamboo tokens. A lot of times it's just just doing things because it's fun, which is good. All kinds of innovations at the beginning. When new technologies come first, people don't always know immediately what the best use case is. So a lot of times it just takes tinkering, experimenting. It's good to have those kind of vibes. On the other side, it's more like how would people call it? Suits or boomer, which is another approach. I would say it's more like a professional. The audience is more, big enterprise, government. It's all about law, compliant, NAR, or VC, COPA, all kinds of things. It's another different approach. I mean, we also need that because the degen is more like end user, consumer ending focus, but the boomer is more like big enterprise, right? So let's say you imagine if you can onboard, Microsoft or IBM, that will be attract because they have millions, sometimes billions of users. You can immediately onboard instead of just go user by user, acquire them in a so-called degen kind of way. So I think there's two approaches. Don't have to be exclusive. I mean, a lot of people here, or maybe even just in the BSV space, think, hey, maybe we can only do one of this. But hey, in reality, we can do both, right? I think if you go to the London conference, I would say it's more like the first approach. I would say because you go there, it's member of parliament, it's the president of the UBS or whatnot. But here we are like, I don't know, more like a grassroots type of a movement, or so-called degen, which is good. I think we need to try both approaches. It's not exclusive. So, doesn't matter which side you're in, or even for us, we support both because we don't know which approach. Some people might hear, they have the foresight to know which one eventually will break out, but we are not sure. So we just support both. So the way we look at this ecosystem and also the Bitcoin technology is is to me, to us, to sCrypt is just another, generation of new, let's say, computing technology. Right? So we have the internet stage, we have the cloud, we have the mobile revolution, and to us, the Bitcoin, the blockchain technology is just another extension or evolution of that. Right? So with all the new technologies, we know, that's supposed to be a gold rush. Okay, so ironically, we are in this place, San Francisco, which is like a fishing village or small town in 1848, and then there's some rumors going on. Hey, just to the west, to the east of this, in Sacramento or Sierra Nevada, there's just somebody found some gold there, and then the people all rush around from over the world. Some people from Asia, some people from Europe, some people from eastern United States. They all come here. They landed here, and then they just go straight to the mountains to try to strike some gold. So this is very similar to what I see in Bitcoin. There's a huge gold mine just under this technology. Whoever can leverage this technology, they can strike gold. Okay, they can make a name or even make a fortune for themselves. But before there's some gold, we can extract out of the ground. We need some tools. So that's for us. We are just one platform. That sits between whoever the Bitcoin, the native, the blockchain itself, the mining network or the infrastructure, and all the app developers. Right? So think about now you just landed here in 1848 or 1850. You want to strike some gold, but you don't want to go there just barehanded, right? So you need food, you need shovels, you need picks, you need shelter. Okay, so that's what we are offering here. So we want you to succeed. We want all the developers here, go out there and use the unique features of Bitcoin to strike some gold, to build the next killer app, the killer app that takes us to mainstream. All right. So we just provide all the tools for all the developers. Whether you are here, you are, let's say, Bitcoin maximalist, or you are just, let's say, chain agnostic these days. Hey, welcome to tinkering. Come to use our tools. Not a problem. So we talk about, the mobile revolution, the cloud. So I just want to give just my, let's say, a little bit of guidance if you are working on the Bitcoin and you want to build the killer app that people can use. So just, I don't know, as I said earlier, I don't know what the killer app is going to be. And if you guys know, either here offline or online, please DM me. I would love to start building today, so I can become overnight success. But for today, up until now, I don't know what the killer app is going to be. But if I have to guess, it probably use some of the unique features, so-called Bitcoin or so-called Web3 can offer. Because if we think that's a technical evolution versus Web 2, so the app probably use some unique features that do not exist in the so-called traditional legacy Web 2 world. For example, Bitcoin, you can do micropayment, as a fraction of a US cent. You could do smart contracts, have a programming logic to control, native satoshis. And later today, I'm going to talk about you can also control ordinals or tokens, right? Tokens, you can tokenize, everything pretty much you can think about, right? And you can do time stamping, and also this offer immutability. You have data, you have a kind of hash, anything that you can put at the blockchain that's accepted. You can be very confident you will not change. Okay, versus so-called Web 2, you put in some kind of database. It doesn't matter which database technology, you can pretty much always update it, delete it. You can also change. You don't have the immutability. Okay. So using an analogy from iPhone, I kind of remember, how How many people have played with, let's say there are 3 games here, or at least know what this game is? Okay, what's this game? Anybody knows?
The wooden piece.
Yeah, Labyrinth, yes.
I played the antique version of it.
Yeah. So here's the question. Can you play this game on PC before iPhone? How do you play this on PC? There's no accelerator, there's no gyroscope there, right? And maybe like a big guy like Kurt, he can lift the PC and play with it, but it's kind of awkward, all right? So it's not that mobile, right? So think about all the games, because they become viral because they use unique features that's only you can find in the new computing platform, which is the iPhone, right? So because it has an accelerator, gyro, and also you have a touch screen, right? So how many people play Angry Bird? Yeah. Okay. So how do you play that without a touch screen? You can use it as a mouse, right? But yeah, it's not as good, right?
It's not the same experience.
How about that one, the third game? Anybody? Yeah. So how many people? I don't know, probably some geeks here. They watched the iPhone 4 launch that's introduced by Steve Jobs. If you have not, yeah, he introduced a new gyro in that launch. It's just another hey, there's one last thing I want to show you. You pull out the iPhone, which has a gyro, and then you start playing the jam. You turn around, walk around. You just remove a few pieces, and eventually the whole thing, collapses. It's just like a real one, right? Which is either impossible or very difficult to achieve in the PC era, right? Because you use the features to either leverage, take advantage of the new computing platform. So, I guess everybody probably use some kind of maps, even for them to navigate here. I don't even know how people navigated before the now kind of thing. I don't know, pull out a map and drive from Arizona or something.
Well, we have books.
Yeah.
Thomas guides.
Yeah. So, but
Taxi drivers.
Just getting lost.
yeah, getting lost. Yeah.
Drive around randomly until you get where you
Yeah, or ask people in real life. Yeah.
actually talk to people, really, guys?
Yeah.
That was a thing.
So.
Yeah, it was.
The range really.
Yeah, well, I remember when I was using some kind of standalone, is a Garmin or
Garmin,
yeah, that's the old days, And then immediately, hey, Google Apps, the maps came out. I was like, I don't have to convince people to buy some coins or they just run. Oh no, they just find utility, right? I don't even have to do marketing. Just hey, people, this is free to use, and everybody looks to me. It's like almost overnight. People even forget, the before what the navigation apps. I don't know that the people, especially for young people, they don't even know that era exists. They cannot even imagine. So I think if there's some kind of killer app coming, it will be similar. We don't have to go probably door to door or do a lot of marketing. Because people can experience the utility, they can understand it, and they're going to love it, and then they're going to tell the friends. I think that's how I see the killer app. If it shows up one day, you probably know, hey, it was like, oh, this is a no-brainer to me because, I don't want to carry my PC and have cellular connectivity all the time and put a GPS next to it. It's not that. You may manage to pull that off if you're like engineers, like you can pull that, but it's not user-friendly, right? It doesn't have GPS and stuff. Same for Instagram, right? So in theory, you can carry a laptop or desktop, has some kind of camera, and then you take pictures and you post it, and what you have for lunch or what meeting you have or some cat photos. You can do it, but it's not as native, as mobile. I think you have to bet on if I'm let's say investor, I want to invest some kind of an app idea, I would, look at all the, does it use some of the unique features? And number one, does it offer utility? Okay. So it's just for all the builders or innovators out there. I think this is this is like we are truly trailblazers, pioneers here. We don't know what the end the app going to be, but we kind of have a sense or guess what's the general direction. If you are just put some Web2 legacy apps, just kind of like awkwardly just port it, migrate it without using some of the unique features, it may probably not be the best option. So think about how you can combine. It's like iPhone app development. They come here, they combine all the unique features: touch screen, GPS, high quality cameras. So similarly, I would say the Bitcoin, you probably want to look at all the different features here, unique, that's not present in the previous generation technology. How to leverage it or even combine this together. And if I have to guess, it's probably not going to take just one iteration. Right? So a lot of people ask me, hey guys, I've been in this here, for 5 years, 4 years, this thing is never going to work. Why? Because we've seen apps pop out there, here and there, but eventually it just looks to me the average users they're not using it. So does this mean it's not a good idea? I would say for people who have been using the first iPhone, I don't know how many people get the iPhone 1. Okay. How many people were satisfied or using it every single day, and all the people they are lined up trying to buy it? How are the apps? What are the apps? Are they good? Any good?
They were good. They were really polished and finished and awesome, but they actually didn't even have the App Store in the beginning. And everybody's like, why don't you have the App Store? And then it was software fit.
Yeah, exactly. If I kind of feel that's the kind of era we're in. We know this technology is going to take us somewhere, but we don't even know exactly where it is. And it's missing a lot of, let's say, infrastructure and tooling. For example, Kevin just mentioned, when iPhone first came out, there's no even App Store. So, it's very difficult to discover good apps, even if you have it somewhere out there. And it's probably not as easy to monetize as you have an App Store, you just put it out there. I mean, even they take a cut, but you still retain most of it, right? So I think for now, we are kind of in the era, we need developers, okay? Developers, again, always developers. That's what we are always for every single day in the past 5 years. We hold conference hackathons here, in Europe, in Asia, in Africa, in South America. I think when eventually we go to the moon, I'm inviting all of you to Antarctica. We're going to have a meetup there. It's going to be a penguin theme, so please anybody who's here, they're all invited here. You are the OG, okay? But we always focus. I watch some JungleBus stuff, to me it's a good show, it's like almost TV drama. But at the end of the day, again, developers, all right? We need the developers to create the next generation of the good apps that are going to take this technology to the mainstream. Why we stand standing here is when I say developers, not only, you don't have to be a coder. Like Taylor, I know you are making good progress, but probably you are not a proficient coder yet.
Not yet.
But you're still, I consider as a developer, because you have ideas. That's the difficulty log, whatever it is. Some people may think it's fun, some people, Jimmy, he may criticize it, but that's okay. We just want to put the ideas out there and turn it into working code, and put it outside and test, an iteration. Hey, maybe we'll first put the first version of Angry Bird there. People still, let's say they cannot use the touchscreen. No, sorry, Jenga there. There's no gyro, or you are not using gyro, or you put the Google Map. It's kind of hacky sometimes. You're taking to to the, if you come to San Francisco, sometimes it's taking you to, I don't know, Oakland or whatever. It's not that accurate. It has bugs, it's shaky, but no problem. I think it's very rare you make the first version and then it just, people love it. A lot of time you probably need to make 10 apps and learn from the mistakes and combine whatever people you find useful and then combine them, right? So for example, we're here, Zuckerberg, right? When he made, Facebook.com, I forget whether it's .com or, whatever it is, in his Harvard dormitory room, he's simultaneously working on at least 10 projects, right? So he's working on some kind of like a peer-to-peer file sharing. He's probably working on something. I don't know. It's just all kinds of things. He released out there. He doesn't even know what people are, because his favorite project actually is a peer-to-peer file sharing. Okay, but then people, for whatever reason, I don't know, like you want to see, judge the appearance of your fellow students. That turns out that's what people like, and he just brings it out there and iterate, to other colleges, and then eventually to, outside of colleges to all the students, and then eventually to the general public, and then moving to different countries, right? So I think the app, the killer app, if it's come out, it may be a similar story there, but we just need to have better toolings and infrastructure, and just have people to move this cycle as short as possible. You don't want to spend half a year to build some Facebook prototype and then release, and then looks like nobody liked it. We want to make this as short, like a weekend, like let's say the hackathon weekend. You build something and release it out there, just testify it. Hey, if it's good, if people like it. If you don't, hey, you just spend one weekend and you learn from whatever what aspect people like or not like. You learn from all the lessons, and then you use it in the next iteration of new apps, right? So that's how I go to see how the Bitcoin, the apps, is just another new generation. But I think the trajectory is almost, to me, is almost surely to be the same. You just need different iterations. We want to minimize the cost, the time. We want you instead of spending 1 year to build something, 1 month, 1 week, even 1 weekend, or even eventually with AI tools, maybe just 1 hour. If you build something, release it out, just test it around, right? So that's always our goal, all day, every day, just focus on how to improve this. So we just talked about some general ideas. I think in the next, half of the presentation, I want to, just give some ideas on what kind of things, people already build, or I would love to see people build. So just, it's not a requirement, or it's just some, to learn from some best use cases. So you can take these ideas, maybe combine with your own unique insights, and let's say build better apps than whatever that's currently available. All right. So, it's going to be a little bit technical, but I'll try to make it. Don't worry if you don't follow everything. All the minor details. That should not be a problem. Okay. So think about. Bitcoin, we talk about, unique features. When we first started, we all think the smart contract. That's the key part. We have the micropayment, we have the immutability, but I think the smart contract is unique because it's so flexible and universal. You can put any logic. Okay, think about the Bitcoin. Okay, so you have inputs at the transaction level. You have inputs and you have outputs. So if the output has not been spent, right, we call it unspent transaction output, which is UTXO. It's like, think about it like a mailbox with lock. So everybody here, I think, has tried some kind of a mailbox, a lockbox. You even have your own address. If somebody wants to send you something, they just put, let's say there's a small opening there, they can insert it, and then if you want to access it, to open it, you need a key, right? Kind of like a private key in the Bitcoin space. But here's where the smart contract side of things, come up, right? So this lock, in the so-called Bitcoin address, you open it with a private key, right? But here's the thing: this lock can be absolutely complex. Can be anything you want in reality. So, for example, you may have a passcode there, which is like almost like a hash log. We in the Bitcoin world, if you set a hash, and then you have to provide whatever value that hashes to it. So this is like a passcode to you. And also you even have time lock. So instead of, hey, even you have the right, let's say, key or passcode, but you cannot open it until, let's say, next halving or whatever, right? So you can add time locks. And you can all combine all this. You can say, hey, Alice needs the key, the Bob needs to have time lock, or one or majority has to vote. You can program arbitrarily complex, maybe even zero knowledge, or even some move math, or you can have arbitrary complex, arbitrary let's say combination of all this to define how you can open this box. Okay, that's what the Bitcoin and smart contract is about. Okay, so this, don't worry about the detail, but in general is, from all other blockchains, you have to learn something new, right? Because so-called Web3, you have to learn some new language, new tools, new workflows, which is not good for adoption, right? So that's why, at the beginning we have the standalone language, but then later on we just find, we love it, but it's very difficult for people to learn, and then also for companies, for projects to hire engineers who already know the tools. It's almost doesn't exist. So that's later on we pivot to the TypeScript, kind of like a dialect. It's pretty much like a JavaScript. So for now, all the 20 million people, JavaScript or TypeScript developer, they don't have to learn anything new. They can just come here, download our dependency. It's just like another library out there. Once you install it, everything you are in JavaScript land. So that can, I think this is the easiest workflow for any smart contract development out there, not only in Bitcoin SV, but in the whole space. You don't have to learn Solidity or Move or some kind of like Rust. You just, as long as you know JavaScript, you are ready to go. Okay. So just to give you how easy this looks like, if you are any kind of developer, I think this should be readable to you. This is what a general Bitcoin address looks like. So address, usually you check two things, right? You put a public key there, make sure it hashes to the address, and also you need to provide a signature that checks out, right? So, if you don't use this, another way to do it, if you're really pro, you can use native Bitcoin script, right? So Bitcoin script, for people who don't know, is the language of the native Bitcoin. It's just some kind of like a assembly or low-level bytecode type thing, which is not, friendly at all. So I think maybe in the world you may have like, I don't know, 10 people or I don't know, 100 people who know how to code this thing, but it's not very user-friendly. So as I said earlier, this is a graph. That's why I think a lot of times so people may feel a little bit of a, let's say our competitors, they already have, so many different ways, everybody going to Ethereum or Solana or whatnot, or the latest Aptos or I don't even Near or whatever. I don't follow the Generation 7 blockchains that closely. But just look at this chart, just give you a sense. In the grand theme of things, that's what the so-called Web3 developer, that's the ecosystem we're looking at. Okay. So versus so-called Web2, let's say just mainstream, more legacy programming kind of things. Look at this compared to that dot. It hardly. I think we just bought a new projector. If we just use the old one, you probably cannot even find it. So that's the kind of stage. It's not as overwhelming as people thought. Okay. So because we pivot to the JavaScript type things, we can immediately capture whatever that's over here. So it's just we kind of like let's say circumvent all our competitors just by directly going to the most popular, the most mainstream that the developer tools out there. Okay. So this is the the latest of what our smart contract technology, is, and is, I think is the simplest out there among all the blockchain development tools out there. And let's say, just give a few examples of what kind of things people already build with this. Okay, just give you a few, I think, examples which I personally like. One is, cross-chain atomic swaps. So for people who have not heard about this term, so atomic swap, let's say we have BSV and somebody, let's say Alice has BSV and Bob has BTC. Okay. What if they want to trade, right? Right now you pretty much have to go to some kind of exchange, some kind of trust third party, and then they swap at the agreed on rate, right? That's called exchange rate, whatever it is. But here, then, that's the issue, right? So, for example, if Alice gives Bob his BSV first, Bob may just run away, right? Vice versa, right? So that's why usually they have to trust on third party, like an exchange or wallet, right? They have to give up their keys. But the problem is, for any kind of third party, first you may have he may run away, right? Or he may even lost your keys, or simply, he doesn't usually do this for free, right? He needs to charge, so it's not ideal. So using contract, we can set up such that this so-called swap is atomic. Either it happens in both directions, meaning one gets the BTC and the other one gets the BSV, or it doesn't go at all, meaning nobody lost his coins. It can never go just one direction. Okay, so you could imagine this, can be trustless exchange for all type of crypto assets, not only for BSV, for any chain that supports a little bit of a contract, you can do this. So the second one, which also go ahead.
I have a question about that. First, the atomic swaps. Let's say that in the future it's only Bitcoin SV that's around, but could you use this same kind of programming for trading, like a subway ticket, or is it the same thing? You know what I mean? Like stock certificates, you're trading stocks.
Yeah,
only between chains.
Yeah, great question. Let me repeat for people who watch online. So Kevin is asking, hey, what if, in a long time horizon, we think there's probably going to be one, let's say, primary or dominant chain. What happens in that case? Is the atomic swap still useful? Yes, the answer is yes. So the same principle used here, it can be applied across different blockchains, but also be in the same. It can also happen in the same blockchain. So that's what we're going to cover in a little bit of more slides here. Basically, we are here to combine the Bitcoin smart contract and tokens. So think about it, right? For example, you have tokenized tickets, and now you may even have let's say, tokenized, stable coin, right? Then if you want to buy the tickets, you can do a swap within the same blockchain, right? You don't have to use swap some blockchain on other tokens on other blockchain. You can use the same technology. Actually, it's the same contract. You can use the same thing to swap access within the same blockchain. I think that's why, the theme of the this event is called, Bitcoin smart contract plus the tokens, because once you have the tokens, you can bring this to another dimension. It just opens new, another dimension which you can innovate on. So let's say, let's jump a little bit forward. So we just talked about the Bitcoin smart contract, right? So think about it, is it like a lockbox or mailbox? Here's the thing. Before the Ordinals or the token integration, you can only lock up native Satoshis in it. Right? Let's say you lock up, 546 Satoshis, and then you want to open it, or you lock, 21 Bitcoins in a lockbox. You want to lock it. You want to open it later. You can place constraints, put all kinds of arbitrary conditions there. But here's the limitation, right? You can only play with Bitcoin, native Bitcoin. What if you want to lock up some, let's say, room, have some kind of access code in hotel rooms, or rental cars, or let's say tickets, right? it's not easy to do that. But thanks to Ordinals tokens, especially one set version, which David is here is mostly responsible for. So thanks for the tokens. Now, not only you can lock up native coins, bitcoins, you can lock up tokens. And the good thing about tokens is anything can be represented by tokens, right? We just I put a few examples here. People have arts, just rock pictures or papers. That's one type thing. You can put land registry, the title, real estate title. You may put even your will or precious metals or real estate. You can there's some let's say I call it tokenization maximum list there. You can tokenize anything because you are pretty much put like a digital representation of whatever that's off chain. You put it on chain. That's what the token is about. So once you have these two combined, is unlimited, really unlimited innovation that can happen because you can leverage the tokens for anything you want to put it on chain. And once you have that, you can combine it with sCrypt, with the Bitcoin smart contract. You can control, you can program arbitrary logic that who can access. For example, you want to, let's say you can, San Diego, right? You want to sell, I don't know, let's say, bus tickets. They can tokenize the tickets, and then once you have some kind of a tokenized, they can even buy with the native satoshis. They can swap it, right? With this all kinds of technology, which is kind of difficult to do before, but thanks to Ordinals, or now you can program arbitrary things, control any kind of even these off-chain assets by combining these two. So I cannot emphasize enough. Before, you can only use the contract to control the transfer, the access of the native satoshis. But right now, because of the unique features, the compatibility between ordinal tokens, you can combine these two, give you another dimension. Go ahead.
Yeah, Xiaohui, how does the tool represent the commodity? Like, how does the contract represent the commodity? That's really my question. Okay, how
does the contract there represent the commodity between the parties in the contract? So you got one guy who's buying art. How does he know he's buying art? How does he know he's going to get it?
Okay, great question. I think so. The way to look at this is it's like x-y axis. Right? You have two dimensions. On one dimension is how do you represent, let's say, the art, right? That's the token part, okay? Which is different from the smart contract side of things. The token part is saying what the underlying asset is. The contract part is saying who owns this, who can move this. So these two are, you can think about that almost diagonal or independent. Does this make sense? For example, you want to tokenize some gold, right? The gold is represented by the tokens. Who can access the gold, or who can transfer it? This is dictated by the smart contract. And these two, because they are orthogonal, you can combine arbitrarily. So you can say, hey, only Gavin can move it, or maybe you need two people to have a multi-sig to sign to have it, or you can even put in a time lock, as say, hey, you cannot move this gold until, let's say you want to send some gold to your kids, right? When he turns 18, you can time lock the gold tokens. He cannot spend it until he legally turns 18. Does it make sense? Okay. Yeah, we have questions over there too. Oh, go ahead, finish.
Another way of saying it. So imagine that the gold or one of these assets is like stored in a vault somewhere, and whoever has the paper slip, the title, they're the one that gets access to it. And so all the smart contracts are, exchanging the paper slip, but whoever owns it and takes it to the physical location is the one that gets it. I think that's how I see it.
So right now, the difference then that, let's say, ownership certificate is on chain, being represented by tokens. So instead of paper, right? So you digitize it, make it more efficient, right? I mean, technically you can mail this to somebody, you have to go there, but it's still, end of the day, it's still physical paper, right? Versus now, it's on chain. You can just with a swipe of finger, you can send it across the globe. It's just more efficient. Make sense? Okay, I think we have some questions over this side.
I'm curious, so if you trade the asset for the token, right, you get the title, do the tokens continue to create more, does it continue to create more value like gold would? I mean, because gold, the price goes up and down, how does that affect the tokenization, like the valuation of the token?
Yeah, I think that's a good question. So for the specific example of tokenized, let's say precious metal like a gold. So think about the token is almost like a mirror version, or we call it digital twins of whatever the physical world is, right? So if you have the gold, and then you have a way to, let's say, link the physical gold with a tokenized version of gold, and now it's on chain, the same valuation of whatever happens in the real world, that's going to be reflected in the token. Right? For example, now I have one gold token, and the gold price, I don't know how much today, I don't know, just say 1,000. It goes up 2,000. And then the value, if the things are right, this token of this, the value of this token now also rise up to 2,000. But if it drops to 500, that value of this token also drops to 500. So it's nothing new. This is just a digital representation of what the real world is. Does this make sense?
Yes.
But there's another digital way of interpreting this. You don't need the gold to back it. You just have this gold meme token, and then you can go up also down. So that's just but that's another story. So, but that also happens too. So,
thank you.
Thank you.
I was just going to ask, how do you look at trusted third parties with physical assets tied to a blockchain contract versus digital assets, right? Because you have like a mortgage title that could be a digital asset with a digital contract, no trusted third party. But then you have gold, which would need to be in a physical location with some sort of third party to protect that gold. So I'm just curious, how do you kind of think of that, or the difference between that?
Yeah, I think the trust, I think my understanding is a spectrum. It's not like a binary, either you have zero trust or you have to fully trust, right? For example, gold. I don't think that's a technical way to, let's say, make sure it's the gold, whatever the token version set it is always fully backed. You kind of have to trust some kind of custody or vault provider. I think, but here's saying that once you have that kind of trust, then the gold can now be regarded on the blockchain, and on the blockchain with smart contract, then you remove a lot of trust assumptions there. But it is still, you see what I mean? It's not 0 or 100%. It's like, so for example, if you walk down a few blocks from here, there's a guy there, he looks, let's say, a little bit not that clear-minded. I wouldn't trust my gold with him, right? Yeah. But if some kind of like Swiss organization who has been holding gold for centuries without a problem, if I can trust them, once I have this token with them, I can then move all my tokens, the gold online, on chain, and then I can do all kinds of things, atomic chain, swap, or even derivatives. Then I can make a lot of things more efficient. At the second level, a second stage, another. I just haven't figured out a way to completely remove, the trust along the whole chain. But even if you can remove the first leg of the chain, you can still have a lot of advantage by moving this assets on chain. Does this make sense?
Yeah, but that makes sense. Which is a bit different though than like a digital asset, or it could be like
for example,
mortgage title could be completely digitized, completely within the blockchain without a third party, right? Because that's sort of a different scenario where it's a piece of paper, a contract saying you own this house or this property or this land, but I guess they're still a physical asset.
Yeah, but you still, in that sense, you still have to rely
There's
so-called
some-
the government,
yeah.
right, to enforce the property rights, right?
Yeah.
So you still, I don't think, a lot of times you don't have to, let's say, even remove all the trust.
Yeah.
Because maybe it's impossible or you don't have to, because if you don't trust the government to enforce the title, we'll probably have a bigger problem to worry about the smart contract, whether that's back over there. Yeah, thanks. Any other questions? I think you're
Kevin answered it.
okay, cool.
Looks like you got 10 minutes.
All right, yeah, let's keep moving. So, I just talked about, the great, the benefit of combining, smart contract together with Bitcoin tokens, because then it opens another dimension. Not only you can control native satoshis, now you can control arbitrary things, right? JPEG NFTs, bamboo tokens, what's the latest, Power 20, whatever it is, you can now control it all, because everything can be tokenized. That means you can, once it's tokenized, it's on the Bitcoin blockchain, you can use any arbitrary smart contract to control how it, who can access it, who can get transferred, all kinds of ways. It just opens another dimension, right? It's like before this integration, which Yiqiang is going to talk about in detail using code. So before this, we combine these two together. We are almost like in a 2D world, right? You have triangles, you have circles, but that's not much. I mean, you can do quite a lot of things, but it's not, I don't think you can build huge skyscrapers. But now we're adding the token dimension, combine these two together. Now we're in the 3D world, okay? You can build, almost like the metals. You can build anything you can think of. So in the remaining talk, I think I'm just going through some example, what kind of things people already built. And again, right, remember, back a few slides, I talked about in general two approaches. One, so-called boomer type thing, and the other more like degen. Okay. So I just show a few, let's say, more boomer type of projects first, and then we can dive into more fun types of degen type of things. Okay. So for people who do not know this project, I think this is the most ambitious project that's currently being worked on by, tokenization for this project is a startup that's based in Cambridge, UK, and by founder. I think most people. Is there anybody here who does not know, who have not heard about Richard Baker here, or raise your hand if you don't know him? Okay. This is probably not a good conference for you, so don't bother. So that's why you learn something new always. So good. This is Richard Baker. He's the former CEO of Tau, which is the biggest mining pool still today. Right before Gorilla Pool. So this is Richard. This is his latest project. Basically, the idea is very simple. So he's from the traditional, financing side of things. He's been like a trader in London for maybe 20 or 30 years. So he noticed a lot of inefficiencies there. So that's why he came up with this idea to tokenize financial instruments, specifically derivatives. Think about, options, swaps, forwards, all this kind of financial instruments. You first tokenize them, and then you can use the Bitcoin smart contract to help facilitate them to trade. How to, let's say, default. What's the condition to default? What's if your interest rate? When do you, let's say, at the end of the day, every day you can settle. You can automate all of these things. So you can, for example, instead of settle in 2 days or even 3 days, hey, you may even do it in, I think in this objective, the target is 0 day. Because as long as it's putting a blockchain, maybe in 10 minutes, it's considered settled. So just think about the efficiency improvement, right? From 2 days, maybe to just some minutes or even 1 hour. Right? That's going to revolutionize this $1 trillion market. I I think for people who have not checked out this, I think they probably have some kind of announcement in the London Blockchain Conference. We are closely working with them to tokenize all the financial derivatives of the world, and then put it on the blockchain and use contract to facilitate, to speed up the trading of this $1 trillion market. I think I'm very bullish about this project, so if you've not heard about it, please take a look. I think it's just called tokenization.com. Okay. So, he's wearing a suit, and then there's another, let's say more, professional type of project with the ideas. So for people, this is a pretty new project, so they contact us. They are incubated in Block Dojo. So for Block Dojo, people have not heard about it. It's kind of like a Y Combinator type of incubator, but mostly focused on Bitcoin SV ecosystem. Okay. So they have this, project called Ideas. So the idea is also very simple. So, people die. It's just the thing, the natural world, how it works. And when you die, you want to make sure all your, let's say assets that are in good hands, right? So traditionally, even Gavin talked about this idea some time ago. It's a will. You need a will. You need to get some lawyers. You need beneficiaries. You have to sign some legal documents. You have to, it's basically short story is complicated, and also it costs a bunch of money. Okay. So what if you want to digitize these things, tokenize all your assets, put it in the blockchain, and then you can put your will in a contract, right? For example, you probably need some kind of a government, like a death certificate from some kind of authority in our blockchain world. That's called an oracle. So once you have this, let's say proof of death for somebody, it will activate this smart contract, and it's going to just automatically, distribute all your existing assets to other beneficiaries. Maybe, Taylor, you have some guns, you want to, give it to your youngest daughter or whatever, instead of, find some lawyers, pay a huge fee. Hey, you can tokenize it as an NFT for your gun. You put it in a contract. I mean, I don't love you to, I don't wish bad things happen to you, but eventually you may perish. So once that's confirmed, the gun, the tokenized gun, go to the youngest daughter as expected, right? So think about it's just more cost effective. So I'm not saying you can completely get rid of all the lawyers involved, but at least you can. Maybe the lawyers, they can build such a system, so it's more efficient and automated, right? So that's another case. And to get this thing wrapped up, I want to talk about more fun side of things. We have order lock, which is traditionally order lock is in some kind of like so-called centralized exchanges. You have an order book, right? So you can match buyers and sellers at some agreed-on price discovery. And then think about order lock, right? So I think quite a few people here, using this to sell all kinds of tokens, or even using bitcoins. So basically, it's its own chain version of the order book. So the benefit is obvious, right? You don't need a trust exchange. Everything is interoperable. It's a trustless because it's just code running by the Bitcoin network, right? Think about it kind of like that. And also, order locker. Okay, who have used order locker? Okay. Yeah. So for people who have not heard about this, you can think about it's kind of like a Twitter, but how do you boost the signal? You can lock up coins instead of likes or retweets. You lock up coins. So the idea is kind of like a signaling mechanism. The more coins you lock up, and for the longer duration, it sends, hey, I'm putting my real dollars behind this post. I really believe this signal. Hey, you may choose to look at this. Okay, so this basic idea is also, some 0xDT guys, he's just programming, I think recently also open sourced it. And the next thing, is also some idea people here have been talking about if you're looking at the spaces. So basically, you can have a smart contract that lock up coins, but not based on time, but based on the difficulty of the blockchain or the mainland. Okay. So the general idea is, for example, I want to lock up the coins. I don't want to sell my coins, especially after some rulings. You may get cold feet. You may say, hey, I want to lock up the coins until the price go to, let's say, 1,200 by the end of the year or whatnot, right? Let's say, hey, you may change your idea, but what if you want to make sure this definitely happens, right? The idea is, we cannot trustly get a price because you probably get it from some oracle, some exchange. But what if the exchange or oracle just, manipulated, right? Somehow being attacked, right? It happens all the time. So the idea is the mining difficulty is an indicator. It's not a precise measurement of price, but usually, the hash that follows the price, right? The idea is, hey, instead of just lock up it until some price, you lock up until some mining difficulty, right? So look at this chart. I mean, it's not exactly magic, but it's pretty good indicator. So what if you say, hey, I lock up of some coins, Bitcoins, or it can be ordinals, right? Until the, difficulty reaches, for example, 1 zettabyte. I cannot move it until it, reaches that difficulty target. I think some people are talking about that idea. Not sure whether it has been implemented. I think David has some kind of like a prototype already, or at least a contract part.
Yeah, the contract's written.
Yeah.
It does that right now.
So yeah, now you have a new way to lock up the coins until it reaches 1,200 by the end of the year. So, and nobody can change that. Once you lock it, there's no, maybe you can find a court order, but other than that, you cannot move it, even if you change mine, okay? So that's another way, a fun way, so-called bamboo. So people who have not heard about this idea, I'm not trying to pump bamboo here, I'm not a bamboo whale, some of the people here, but it's a general, so that's why I like the idea. It's just, it's not just saying, hey, this is the final form of the killer app. It's just some way, new innovation that's come along, how to combine, the minting of some token together. You can control it with a contract. This is the first implementation of that, so that's why I want to highlight the use case. I'm not proposing you aping to the, aping the bamboo, but just saying this some new tool set. It's like an iPhone set now as a gyro or high quality camera. So there's something you can leverage now in all your apps. It just opens new possibilities. Okay. So for people who not know about this, basically when you mint, instead of just paying transaction to mint it, you need to lock up some coins. Okay. So this is something, for example, you cannot do on BTC. There's no contract there. They cannot do lock to mint. Okay. And also talked about earlier to extend the idea, which I think Kevin also briefly mentioned. So you can extend the atomic swap from just across chains at different BTC with BSV, for example. Right now you can use the Bitcoin too, because Ordinals can also be put in this contract. You can use, you can swap Bitcoin with Ordinals, for example. And Ordinals can represent anything. Right? Or you can some other protocols, as long as it's compatible, token protocol that's compatible with sCrypt, then you can use it to also atomic swap, Bitcoin with Ordinals and Ordinals with Ordinals. You may have some bamboo, I have some OBGK, if you want to trade, you can swap them. Okay, no problem. And this is also all in the direction. So we think in our blockchain we are the most performant in stuff, speed, throughput, transaction fee. Hey, some other blockchains, let's say BTC or Ethereum, they may have some, let's say, gas problem, right? Because whenever they have a huge hit by a huge volume, the chain pretty much get clogged up. It's slow, it's expensive. Hey, if you want, we'll welcome you to transform to our land. It's like, all your roads are clogged, no problem. We are 3D, we have all the planes. You can move your assets, kind of like a wrap token type thing. Once you have the bridge, you can come to our land, and do all the stuff, yielding, farming, DeFi, whatever you want. You can move it to our blockchain. You can do all the things here, and then when you want to exit, you can withdraw. Right? So I think several teams are also using this. So this is just I would say a little bit of a non-maximalist, but we are here. This is technology. If other blockchains want to leverage this, you're more than welcome to come here and join. To leverage all the great advantage we offer. So, this is one example. For example, the bridge. The problem is you need to trust the bridge operator. Right? The general idea is you deposit some, let's say BTC in some kind of address, and then the equivalent wrapped token will be minted on BSV. But what if the operators, malicious, are being attacked? Right? So one way to do it, let's say that requires less trust, is using a contract to mint tokens. How that works is, I think people are already tinkering with this idea like a difficulty lock. So the idea is you do the SPV check here. You can make sure actually some BTC has been deposited to, let's say, address A of BTC. You can check this in the smart contract. And once that's passed, right, again, you can use this rule to mint the wrapped tokens. So you don't have to trust the bridge operator. Everything is trusted in this direction at least. Okay. So another example I think people already been using is using proof of work to mint. Right? For example, right now how to do fair launch is, whenever you are ready, you just send transactions. As long as you pay the fee, you are good. Right? But then people complain, hey, now all the big whales are swapping all the, they're swapping they're getting all the goodies. It's the early stage. I want to be more so-called fair. One way to do this is, hey, also apply the proof of work principle. You can come here. Hey, you need to, not only you have to pay, but also you need to find me some mini proof of work, do some kind of mini proof of work. For example, you need to hash this thing till you get, 20 leading zeros or 30. So, and then you can get, you can mint your token. You can claim the tokens. Right? You can have all kinds of arbitrary ways. Right? I just give you a few. You can even say, hey, only people in this whitelist, in this address, that's like Merkle tree, only these people can mint. Right? I don't care within this group, I don't get the order, but it's a whitelist. You can blacklist, you can freeze, you can say, hey, only the issuer has to sign, also co-sign. You can add all kinds of rules. It's upstream into the how to mint the tokens and also how you transfer the tokens. Okay, too. So this is all the example I want to cover. And at the last few slides, I just want to mention, what are all the other developer tools, you can leverage to combine, which are not, we were working with the ecosystem, for example. Dance here, is yours wallet. It supports Bitcoin, smart contract, and Ordinals. If you're a developer, you don't have to build your own wallet. This is like MetaMask equivalent, but for the Bitcoin world. So you guys, all the unique features listed here. You can always give it a try, and it works perfectly with sCrypt. Now it's called yours. So we also have a What's on Chain plugin. You can go there once if you have a BSV candy, you want to check out what are the details. You don't have to look at the JSON, which you can do, but it's not user friendly. So we also release the What's on Chain plugin, and also we work with all the, let's say, transaction process on traditional miners in the system. We have Curve, we have a Gorilla here. We also internally use the Bitails and Tau APIs to read and write to the blockchain. So yeah, that's the end of the talk, and it's time to keep building. Thank you. Any other questions? Yeah, get the.
I think Craig Wright said that life is not fair, or competition, or we're not equal. People have different skills at Oxford, right? He said that. It's clear to me you're smarter than the rest of people in this room. Why do you pitch us? Why don't you just build all these things? Like, we can help you if you build.
instead of building tooling for us. My general background is, instead of, like, obviously Bitcoin can build anything. Okay. But the rest of the world doesn't even agree that BSV is Bitcoin. And that's the case unless BSV flips BTC. So our mindset should not be, let's just, hey, I built a tool for you, developer, you can build, oh, you want to build a little dance kit? Okay, cool. You want to build a little, like, ballet thing? Cool. You want to build a Panda wallet? Cool. Why don't we have a mindset like, let's build vampire attacks like we're Al-Qaeda and they're the United States, and, like, let's just go build things to attack BTC. What do you think about that?
Okay, that's quite a few points over there. Okay, first.
How about that, Xiaohui? What do you say?
Yeah. Okay, to address that, first, I'm not smarter than, it's just the sum of whatever people.
I'm only smart enough 3 years later to understand what you've been doing this whole time.
Okay.
And so now I'm like, oh, we all want to show up, we want to work on this. 3 years ago, I'm confused. I'm on Run, I'm on doing this other stuff, Twitch is on Signal. We're only understanding this now. So think about this. You've been trying to convince us for 3 years what you're doing is important.
Yeah.
Just forget about us and just get going with it.
Yeah, I mean, one thing I would love to, people, whenever I send messages and people, everybody's on the same page. I think it rarely happens in the real world. It's think about Craig, right? He's been saying things, I don't know, which now takes for granted, right? Tranquilities or whatnot, for the past, I don't know, 9 years, 2015. So that's usually the lag between, what is we think is true, what is important between when people take it. I get you. Okay. Before people can fully understand it. Okay.
Anyways, hopefully we can help you now.
Yes. Okay. Finally. Okay. Sketch out. So back to the building. So here's the thing, right? As you said, it's not fair. Which I think is fair, right? People have different skills, right? Well, that's what makes us human, right? Some people are good at basketball, some people are good at guns, some people are good at, YouTubing, some people are good at growing their own vegetables. I'm not good at none of this, but here's the thing, right? I'm not good at, let's say, app developers, the end users or UI stuff, right? I don't design the yours, let's say, UI. I'm not good at it. I'm not a CSS or design UX expert. So I'm good at providing the ideas, the toolings. Yeah, to me, I would love to build some kind of apps if I know. But for us, is we are a small team. We already have a lot of things on our plate. We cannot do everything, and we are not trying to do everything, and we cannot do everything. So that's why we always, give out all the ideas for free out there. It's working demo code. So the idea is that other people take it from there and build the fully functional apps. Okay. So that's the idea. As I said, I cannot do everything. We're resource limited as everybody else, and I'm not good at building, let's say consumer apps or even boomer apps, whatever that is, to the government. I don't build CRMs or or marketing apps. I'm not good at them. I'm not like a Salesforce. So that's a short story. We want to work at the levels that's underlying, that empower all the builders here, and you guys are going to take it from there. We offer the picks and shovels. I'm not good at penning gold, in some Sacramento River or American River. You guys are going out there, exploit, to extract some good.
Because when your platform gets popular, you have achieved scale.
Yes. We are. Exactly.
I would also say,
I would also say that Jack's question is a little bit like, why would the mayor or the governor or the president not do every job in their municipality? See what I mean?
Mm-hmm.
The mayor is establishing this framework so that everybody can build their own businesses. But one individual, or even a small tribe, let's say, the groups you mentioned, they can't build LA, they can't build New York or United States. So it's about specialization and letting people do different tasks.
here we just want to offer the best tools and the infrastructure so people can come here easily in the fastest way to build apps. Think about Bitcoin is also the same. I mean, Craig, he probably knows how to build all kinds of these things, but I don't think he has the time or the energy or the expertise, even for him, to build even a wallet. He's not good at the front end. Same thing here. We all get different skills, right? Even for the Teranode, or previously called iDemon, right? He has this idea, but he's an architect kind of guy. It's taking him 10 years, maybe even longer, to have something that's close to production. I think we're going to hear more about it tomorrow by Jake. So yeah, we all have our roles to play, and I'm good at infrastructure, tooling kind of things, but you guys are good at whatever you guys are good at. Yeah.
Yeah, so I just wanted to build a little bit on the idea, though, which is that the tools would be more useful if there were consultants or service providers that could basically be contracted by people that know what they want but aren't able to learn and then make use of the tools. So if you have made a tool and then you've got downtime and there's people that really would like the benefit of a tool that could be made use of, then I think there's a gap there. So.
Okay, if I understand you correctly, you're saying, hey, maybe somebody, let's say here, right? A lot of people were developers here, coders, but what if, I don't know how to go, but can I still leverage this kind of tools? Is that what you're asking? Yeah, so no problem. Either, we offer also, professional services for people who want to use our tools, but they don't have the know-how to pull this off. We are welcome to reach out to us, and we will help you to build whatever your app is. Right? So we're happy to do that. Second, we all have the top coders here. A lot of people, they have the coding skill, but they may not have to know what apps that's going to find the product market fit, right? So if you have that kind of ideas, mingle with the coders, it seems like a better team to, have technical and non-technical founders to join forces, and that's another way to go. So basic story is, bottom line, if you're not a coder, it's not a block. It's not a showstopper. You can always find people that can code it up for you. You don't have to be. I think that's a misconception, or even, maybe sometimes even intentionally put out by coders to make them feel that they're the smartest guys, which a lot of times is not the case. Okay, if you go ahead.
Yeah, I just wanted to add that it's about achieving escape velocity. That we had cars for 50 years before they became a commercial entity, and that was largely because of Henry Ford, both as an engineer for process and as a marketing genius.
It's the same thing with, there were cheeseburgers for 50 years before Ray Kroc took over, and so it's about what is the thing that gives us escape velocity, and I don't think anybody's actually figured that out in the blockchain space. I mean, we slowly bring people in, and even the whole blockchain space as a total has a lot more people than it did 5 years ago, but there's still, we're in one of the tech capitals of the world right now, and I bet if we were to stand on the street corner and say, who here has a wallet of any kind holding any kind of digital asset, it'd be pretty high in San Francisco as a percentage, but it would still be quite low, I imagine, just the average person walking by. So we have not gotten to the point where anybody has the use of the technology the same way that I think essentially everybody's gotten a Big Mac or chicken nuggets in a drive-through. Just even by even if they don't want to and they don't eat that food, they've just been it's the most convenient thing I have to eat.
And we don't know what that is yet. So that sort of the entrepreneurship aspect of it is still very, very small, very unsophisticated, and it's crucial. So somebody's got to figure out that thing that makes everybody say, I may not even like that tag or that idea, but I'm going to participate in it because it's a necessity.
It's useful, yeah. Another
We can hear them anyway.
It's mostly for people online. Yeah. But I can repeat the question. It's fine.
You have everything 30 feet now.
So I think, like the Red Hot Chili Peppers said, you got to give it away now. Give it away now. What I mean by saying that is, for example, if the tool is simple to provide everybody with a digital token of each one of the slides in this presentation, then people who make presentations would just hand out a wallet to people when they walk in or out of a venue like this, and they would take the slides home with them. And it would be free. They wouldn't have to pay for it. Because the person who creates the presentation would just say, I want everybody who attended to have the slides. They can do what they want with them. And it's cheap. It's cheaper than paper. I think so, anyway.
Yeah.
That's it.
Yeah, you can easily go there. We have an inscription service. Go to our webpage. You can inscribe any format, file format. You can inscribe pictures. You can put I think just for fun, we can put the slides over there and then to mint it as NFT and then send to people here in yours wallet or I don't know if any other wallet that people usually use. But yeah, you can it's easy to do. You don't need a coder even. Just go to inscribe.sCrypt.io. You can inscribe your file there, and it will just show up in your yours wallet. You can send it around. Virtually for free. Yeah.
That is an NFT or an Ordinals?
Yeah, NFT is Ordinal. So. Any other thing? Yeah. Gavin, do you have something? Or?
No, just whenever you're done, we should bring up the case.
Yeah, he wants to ask.
I got it. Oh, yeah, bring up. Yeah, sounds like there's one question here. Yeah.
So, Xiaohui, are you working on BitVM, and what is your relationship like with the BTC Ordinals guys?
I'm not working on BitVM, but yeah, for me, but I keep an eye on all the, what are the cool boys doing on all other blockchains, just to make sure, if they have some good ideas, we can always learn from them. I'm not, let's say, that maximalist in that sense, because I do look over the fancies sometimes to check out what the other people are doing. I'm not using them for two reasons, I would say. Number one, there's nothing that BitVM can do that you cannot do with us. So that's number one. Number two, we have a lot of things we can do they cannot do. So I think they're like a super small set of things that BitVM, even is working today, they can do. It's a minimum set. So I check them, but I just I don't find them very useful. Okay, and I do heard from one of the creators, he's saying at least Amy is saying, Super Testnet is partially inspired by what kind of work we are doing. So I'm really happy. That
did they approach you about investment?
BitVM?
Or like the BTC guys?
There are a few people reach out when I think when it first was disclosed that BitVM was kind of partially inspired by us, but later on they all backtracked. I don't know why, but the ping us, hey, they invite me to podcast and to some kind of like I don't know, even Bitcoin magazine, they invite me for some articles, but later on they all backtrack. I don't know why, but
I think you know why.
probably they got self-censored or they got cancelled if they do. So not a problem. Thanks.
Oh, check. So you kind of glazed over this, but you're talking about the like trustless bridge.
Okay.
Between BTC and BSV, that's possible. Yeah. Can you just flesh that out just a little bit more for maybe non-technical listeners?
Yeah, sure. So the way traditional bridges across different blockchains work, you kind of have a, let's say, a bridge operator. It's almost like a, it's almost like an escrow. You have to trust him with your coin, right? For example, let's say you want to bridge from BTC to BSV, right? Traditionally, it's done, you send, let's say we have a multi-sig address, you send to the, let's say, the bridge operator. Once I have your one BTC, I'm going to, on the other hand, on BSV side, we're going to mint one, let's say, wrapped BTC tokens on BSV, which represent your BTC on BTC land, okay? But the problem, and vice versa, when you want to withdraw, you burn this one wrap tokens, you destroy it, and then once the operator can see this, they can give you back the one BTC, right? But the problem here is always the trust issue, right? Either the operator is malicious, he can just run with your money, kind of like a centralized exchange, or they may get hacked, as they always do somehow. Every single time, maybe every week, you got some bridge operator bridge got hacked and user funds are lost. But here, in the bridge world, the holy grail is so-called two-way trustless pack, meaning going either direction is trustless. You don't have to trust anybody. It's all enforced by the code, by the smart contract. But here, instead of doing full two-way trustless pack, we only can do one direction. Because the reason is because once you deposit the BTC, right, you can, in the BSV side, inside the smart contract, you can do kind of like an SPV check, basically says, hey, do I really receive, let's say, one BTC from, Alice? Once you have that, you can mint. You can mint using smart contract to mint one, let's say, BSV20 token to Alice's address, right? Because private key that compatible is the same. So that's a mechanism, but unfortunately, you cannot do the other way around because BTC pretty much don't have contract. You cannot verify SPV there. But at least it's better than you have to trust both directions, right? So one-way pack, trusted pack is better than none, but it's not as good as two-way. But unless they upgrade, maybe have an opcat or add some kind of opcode, we can do that too. That is two-way. So the benefit is once you have a BSV land, everything is frictionless, instant, cheap. You can combine with arbitrary. You have what?
Trustlessly go back to
BTC.
What about how does this relate to the atomic swaps? Because that goes both ways, right?
Yeah, good question. The problem is, okay, so usually when you go cross-chain, you have two approaches. One is bridge, the other is atomic swap. So atomic swap, right? But the biggest problem is the liquidity, right? It's like a bartering. I have one, let's say BTC, I don't know the exchange rate today, let's say 1,000. Okay, one BTC, you have to exchange for 1,000 BSV. Okay, maybe one day we have a parity. Anyway, so you have one BTC, you have to find another guy who's willing to take you give you 1,000 BSV, right? But again, it's like barter. What if I want 0.5 BTC, or I don't have, or I want 1.3 BTC? It's not going to work out. I think it's so usually in reality, how people work is for large amount, a pool of funds, they use the bridge to bridge over. Once you have the pool, you can have atomic swap between that. But yeah, it's great observation. Does this make sense? So for big amount, usually it's bridge across. But once you have pools, you can do atomic swap because you have pool.
You can pool liquidity to go to
atomic swap, yes. Atomic swap goes both ways. Yeah.
Not to go from BTC.
But the bridge is like if you want to have trustless pack.
You have a trustless bridge going from BTC to BSV, then you need a pool of liquidity to go back to BTC.
Yeah, if you don't want to have like a trust third party, yes.
So you could have one side of the liquidity pool to go back.
Yeah. You can even have two sides too. You can also have another, yeah. Mm-hmm. But maybe they add some opcode and stuff, and later on we can do also two-way. But that's like holy grail of bridges or side chains, whatever they call it.
All right, well, thank you very much, Xiaohui.
Okay, thank you, guys.
It was a great presentation. A lot covered there. All right, so now let's try to get David's slides up. So David Case will be our next presenter. Let me just go ahead and you'll have to bear with me here for just a second. I'm just going to do my best here to bring this up. I believe that's going to be Ordinals and sCrypt. Is this the right one? Looks like it. Okay, let's just go ahead and present this. And everybody can see the slides, it looks like, so make sure. Yeah, the audio keeps cutting in and out. So basically this thing, or the mics have to be within about 20 feet of this receiver.
If you have
so
a question or you want to make a comment, I think we should.
I'd like you to come up to the front.
So the complaints were with Xiaohui's mic.
Oh, it probably was a little bit of interference.
Echo?
Yeah.
Yeah, so I've been trying to adjust that with the speaker down below. I think the problem is the speaker. Can everybody hear?
Is it everyone in this room can hear?
Okay. Well, I just turned the speaker way down.
Right.
We might not even need the speaker if you guys can hear the speaker. So I'll
Okay.
just turn it all the way.
Let's turn that speaker down then, and we'll just use the mics for the purpose of streaming. It's good to have it up just a tad bit so we can tell whether the audience mics are being picked up. But yeah, I think it should be good. Yeah. So like I said before, great presentation by Xiaohui. Covered a lot there with the iPhone, and one thing that really stuck with me there was developers, right? We need that in our space. We need people building stuff because Xiaohui can't do it himself. We all provide really great tools, but speaking of really great developers and people who have built some really cool things, David Case, give a warm welcome to him. And here you are.
Hello. This is going to be pretty informal, and I'd like it to be interactive as well. So make sure to think up questions as you're going through. So I'm going to basically cover, first of all, what ordinals are, and then get into a number of the different ways that you can interact with them using sCrypt. This will be a fairly technical talk. Discussion, whatever. So I'm sorry, it's kind of the way that I work. Innovative, but really, really sloppy at the same time. So that's why you get black and white, no fancy graphics here. All right. Does this work? All right, so what is an ordinal, first of all? An ordinal is really nothing more than a globally unique identifier, associated to every Satoshi that exists on Bitcoin. They are created when new coins are created. That ordinal is created at that point in time, and it is literally just that Satoshi. So when a new block is created and new coins are spit out, those are newly created ordinals, and each one of them has their own serial number. There are rules for tracking Satoshis across multiple transactions, which is kind of the rules of their ordinality. We'll get into that in a second. And the whole concept of ordinals can be fairly computationally expensive just because there are, however many quadrillion Satoshis there are in the world. If you're going to track every one of them, where they exist and how they've been throughout the history of the chain, that's a lot of data. So getting into actually what this is. So here I've got mocked up kind of the block headers here. We've got block 1, we've got block header 2. Block header 2, where the coin base came and 50 new Bitcoins were created, essentially, at that point in time, ordinals, there's a lot of different nomenclature for how you write these things out, but essentially, it was 0 through 4999999 that came up when block 2 was created. Block 3 created, you got the same thing again with 2.0 through 2.50 billion, or 5 billion. So there's just a huge amount of these, and it really is, these are all the Satoshis that exist on the chain. So the rules for kind of tracking ordinals as they are transferred from one transaction to another. is not about inputs mapping to outputs in any sort of way where you've got, okay, this UTXO. So not in the sort of way that you would have a sig hash single where one input equals one output and those are attached together. It's actually more literally tracking the 0th Satoshi that comes into a transaction transfers out to the 0th Satoshi that comes out of the transaction. So here in this transaction right here, we've got a 1 Satoshi input, which maps to a 1 Satoshi output. We've got a 100 Satoshi input. Those ordinals are essentially transferred 40 here, 60 here, and then the next 1 Satoshi input we have will transfer through so that it is it's transferred through on this output, and then the rest doesn't really matter. So it's tracking through, lining up every Satoshi that comes into a transaction, every Satoshi that comes out of a transaction, and they just follow it through. So wherever that 1 Satoshi moved, that ordinal has now moved to the UTXO that holds that. There's some other complexities about what happens when there change and stuff. That doesn't really apply on what we're doing on BSV, because BSV, everything we're doing is about one set ordinals. And a one set ordinal is essentially taking the BTC concept of ordinals and building a more specific token protocol on top of it. So in one set ordinals world, we have this concept of an origin. And an origin is simply the place on the blockchain where, actually let me go back here for a second. Does this have a laser pointer on it?
It does. The center button.
All right, yep, got it. So in our first transaction over here, we have 0 Satoshis going in and 1 Satoshi going out. So in the one set ordinals world, this is the creation of a new token. It's just as soon as 1 Satoshi exists in an output by itself, that is a token. And as soon as it spends through, this ordinal transfers from this transaction to this transaction, and it doesn't get disappeared. But let me go back up here. No. Yes. So an origin in one set takes the form of the transaction ID underscore the output identifier. So simply what UTXO on the blockchain's history did this origin get created. And every time we spend that 1 Satoshi throughout different transactions, it'll always be indicated as these are updates of this specific origin. So this origin has moved. So if we go back to this concept where in the BTC world dealing with origin, the identifier is literally, there are quadrillions of identifiers out there. We kind of skip all that part where one set ordinals isn't really trying to figure out which ordinal, which Satoshi is being spent. All it really cares about is telling that multiple transactions are the same ordinal. So I don't need to know that this Satoshi came into existence in block 423,000 and that it was the 18th Satoshi that came out. That doesn't matter. What really matters is the point where it becomes this 1 Satoshi output by itself. This token has come into existence, and at the point where the Satoshi is transferred into a bigger output than 1 Satoshi, that token is burned. So we're using all the concepts of ordinals on BTC, but just kind of making a new token protocol on top of those with a much shorter lifespan of where has that Satoshi been, or like I don't care where it came from. I care about when it was created as a single Satoshi and when it stopped being a single Satoshi, and that is the lifetime of a one set ordinal. So ordinals are, again, that's really about simply tokenizing every Satoshi on chain and following it. In the ordinals world on BTC and also in one set ordinals on BSV, there's this concept of inscriptions. An inscription is really just saying, okay, I've got this history of the blockchain, and at this one transaction, at this one place in history, I have, like in an archaeology standpoint, I have inscribed data. I've chiseled into the cave wall a picture, a JPEG, a PNG, a PDF. It doesn't matter, an audio file. what has been recorded against that one ordinal on chain is some data. Someone chiseled into the cave wall a painting of a horse and a dude on it shooting a deer. And that is forever, at that point of history, was what something put on that cave wall. And so when we're dealing with ordinals, we can go back the history of the chain and follow that ordinal back to a point and see everything that has been inscribed on that actual Satoshi in its history. And a inscription takes the form of this little bit of script right here. So this is essentially a no-op, which means you can include this anywhere in your script, and it's not going to affect the execution of your script in any way. It basically just says, here's false, and I have a loop that says, if true, do this stuff. Well, I just said false, so it will never, ever be true. So this is essentially unexecutable code that just goes in your Bitcoin script. And what it includes in the case of an inscription is a content type, which is saying, okay, this is a JPEG, or this is an HTML page, or a PDF, or whatever. And then actually a big blob of binary that says, here's the file. So this is the same way, or if you go to a URL on your web browser and you say, okay, give me cswrules.jpg, it's going to give you a header that says, all right, here's a JPEG, and it's going to give you a binary file that is, I don't know, a picture of Craig flipping someone off or something. So then these inscription envelopes can get stuck into literally any type of Bitcoin script there is. So there's an example here of just a regular old pay to public key hash. We're just sticking the ordinal envelope at the beginning. We got the pay to public key hash at the end. You can have a multi-sig lock. You can have sCrypt contract. And you can even use opcode separator to do different, more complex logic, or to make it so that in order to sign these trends, well, that's too technical. Don't need to get into that. But anyways, there's lots and lots of different ways that you can stick an inscription in your script. And really the only thing we're looking for at any point is if this is a valid inscription, is there a valid inscription envelope? And if there is, this is an inscription that happened on chain. All right, so now that kind of preliminary, I'm going to actually go through a little bit of some examples that I have built to kind of work with ordinals in an sCrypt world, or with sCrypt as a tool. So Xiaohui already pointed out the ordinal lock, but I just wanted to kind of step through a little bit what's happening here. So in this case, essentially, you've got an ordinal. You've got a really, really cool frog that you own that maybe is gay. I don't know. So you've got this frog ordinal, and you want to sell it for 1 BSV. So what you actually do is you're transferring your frog to a new owner, and that new owner isn't anyone's address. It is an sCrypt contract that is created, and when it's created, you pass in, okay, a public key hash of who you are, who's selling it, and an output script that someone needs to pay in order to unlock this frog. And this contract has two methods. One, at the bottom here, the person who listed it can at any point just say, I don't want to sell this anymore. I'm going to just take this back. It's in my wallet. It's canceled. But the other option we have up here is purchase. And so this is sitting out on the blockchain. Your frog ordinal lives out there. It's owned by this contract. Any person, by calling this purchase, can take over that ordinal from you, can take ownership from you, without any signature from you, without any signature from anyone else. All they have to do is make sure that the transaction that they're spending this in, where they're taking ownership of it, they have got in there a payment to you for whatever, for your 1 BSV that you're asking. And so this really unlocks some really cool concepts of locking up things in such a way that you don't actually ever, like, if I lock up this frog, it's never getting unlocked unless someone pays me money or I unlock it. And so I have total control over that, but anyone can take it, again, by paying the price that I'm setting. Any questions on how any of that works from anyone? No. All right. So this is one I haven't released anywhere yet. This is the OneSat store. And to get into that, we need to go through a little bit more background. So again, inscriptions are files that exist on the blockchain, and they're identified by the out point where on the chain they are inscribed. A recursive inscription is essentially creating an inscription that in the tools in which you render to view that, it can parse data and make sense of other data. So in this case here, we've got an HTML page. So I'm creating an inscription that is it's a simple web page. And so its content type is web, and then here's the actual body of the inscription, this HTML right here. Well, you notice the script tag in the HTML has a /content/ an outpoint identifier of another inscription. And then in the body, it's got an image link to another inscription. And if you load this up within from a web server that actually knows about these recursive inscriptions through a web browser, what you will actually see is the web page that pulls in whatever script is referenced here and shows the image of whatever's referenced here, which means we can start having very dynamic, full internet, like literally your web browser can be browsing ordinals directly. And so by pointing to a website that is an ordinal, that has references to other ordinals, that has links to other ordinals, that has JavaScript code that takes in the logic of all those other things, you end up with a fully on-chain computer, essentially, where people can interact with the chain in the native language that they're interacting always, which is just through a web browser. And you write new data to the chain by actually making transactions. And other than that, you're just building this huge internet, World Wide Web. It's really what it is of, I have this file, which links to this file, which links to this file, and you can get stuck in a wiki loop where you're just sucked into how deep this goes. But there is no like one entry point. There is the place where you got into things, and then all that is just linking to other things that are on the chain.
So Zhang Gao devoted practically a whole chapter to this. Did you
No.
In his book, yep.
Oh.
It's super cool. It's super cool. That's
Wait, to recursive encrypt, like
recursive inscription?
to OrdFS?
Yes.
Oh, that's cool. No, I didn't know that. I will have to. So ordfs.network is a site where we actually serve these things up. So if you go to ordfs.network /content/any inscription ID, it will serve that up, and then you can actually navigate through all the other ones from there. And there's some other like stuff we played with of actually tying your real-world DNS records, where you can register an inscription ID or one of these, an origin basically, to your domain, and then with the right server software and the right DNS records, you can actually, when you go to that domain, it is going to look up in DNS, figure out what the root origin is of essentially this recursive inscription. And so I can go to, I'm not sure if it's still up, but I used to be, if I went to ordinals.sugar.cloud, which is my website, or one of my domains, that was using this, would serve up a specific ordinal. And so from a web browser, you type in just my regular old domain, and what you have is a regular old website, but everything is coming from on-chain. Okay, so to take this concept of recursive inscriptions, I want to show up this OneSat store contract I wrote, I don't know, probably 6 or 7 months ago. And what OneSat store is, it's basically a generative art vending machine. So if I've got, let's say, I don't know, one of these, I'm pretty unplugged from the degen space, even though I'm all about the tools for the degen space. So pick your ordinal collection, your generative thing where you've got, let's go with, what's that? I don't know anything about that. So we can go with the squatting Slavs there. You got the same basic idea from the Gopniks of there's a dude, he's squatting, his hands are, whatever, he's squatting. We got that, dude. And then through random number generation and through a bunch of different stuff, in one of them he's got a plaid t-shirt, he's got a cigarette and a gun, and the next one he's got a beanie and maybe he's, I don't know, like all these different combinations where how they built these is they're just layers upon layers. Okay, here's the basic thing, then here's the shirt layer, and here's the hat layer, and here's the accessory in their hand layer. And they just run things through a random number generator. They're just like, okay, for this layer, let me roll the dice. Okay, it's the 5th shirt, the 47th hat, and the 3rd pair of pants. And that's what this Gopnik looks like. So this contract kind of takes that and puts the random number generation side of it and puts it on chain. So when if I create a website that has got built as a recursive inscription that has built in, okay, here are my 9 layers of pants and my 47 layers of headgear and whatever else, and all those individual assets are put on chain as inscriptions. Well, I can write JavaScript code that basically just takes a random number and figures out which of those things I've got on each layer, layers them up, and shows a web page that is my specific, my specific combination of all that logic. But the whole thing there needs some aspect of randomness, like what triggers which pants you get, and which shirt you get, and which hat you get. So this one-set store is basically an idea that says, okay, I create this one kind of master inscription, I deploy into this contract kind of all the master resources. And this contract, so I lock into it, okay, that's the same basic thing as the ordinal lock of who do you got to pay, or what do you got to pay in order to get one of the new ordinals generated. Price, so then we break the actual content. The actual HTML and JavaScript that's coming into this inscription actually gets broken up into a prefix and a suffix. And essentially, by the prefix ending with a set of quotes and the suffix beginning with a set of quotes, what this contract is going to do is just stick a random string of data in between those 2 quotes to basically string build your full HTML page that has a random number generated, pseudo-random number inserted into it. So I'm deploying this thing, I'm setting all these initial variables. And then when we go to actually purchase it, we're actually going to build an inscription that puts together, please tell me I didn't include that in here. Oh, next page. So when I'm actually building things, like what I'm sticking together is the prefix plus the transaction ID of the previous input. So every time we get a new transaction ID that was where this out point lived. So every time you spend it, that transaction ID is going to just get stuck in between your prefix and your suffix, which is now your seed of your random number generator. So if you deploy a project into a one-set store, every time someone spends to you, it spits out a brand new ordinal with the transaction ID that you just called stuck into that. And so the code will render out your variation based on that transaction ID. The next person who buys it gets a completely different one. And so on. So like that randomness will always be based on the previous transaction ID, or where the current transaction ID, I guess, of where this output lived. And so it can just inject that randomness, everyone gets a different thing, but it's all creating the exact same template, JSON file, the exact same recursive inscription, but with a different transaction ID stuck in that randomness. So another thing that Xiaohui went over a little bit is this lock to mint contract. And this gets into kind of another concept where we need to cover some new stuff. So BSV 20 is, or in this case, it was BSV 20 v2. BSV 21 is kind of the labeling going around it here. But taking the concept of NFTs, not fungible tokens, and using what Ordinals brings for kind of embedding data on chain to define a new way of doing fungible tokens. BSV 20 is by no means the epitome of how everything should be done right in software design, but it's kind of a cool thing that started out with one very, very degen idea V2 then came a little less degen of like, okay, how can we do actual stuff with this? And so what is now called BSV21, the V2 of BSV20 tokens, is mostly been used to this point from the idea that says, this token is deployed. Well, I'll start with that part first. So deploying a token is literally as simply as creating an inscription with a content type of application BSV20 and a JSON file as the body that looks like this. So in this case, 21 million. I mean, that's actually 2.1 billion, but there's 2 decimal places. So it's 21 million coins with 2 decimal places. And as soon as I write that code in an inscription on an output, this token now exists, and there are 21 million of those coins that exist. And then when you transfer BSV21s, it's actually spending, it's a UTXO set just like Bitcoin. So your inputs are whatever the old outputs were where the tokens lived. The input, or then the outputs are how are you allocating the tokens that came in. So here, all 21 million came in. I'm giving, I don't know, 1 million there and 20 million there. So as soon as you make a deploy contract, we've got this concept of a token ID. Token ID is just simply where did this output exist. So in transaction ID 1, 2, 3, 4, blah blah blah. Output 0. I guess I never say. Oh yeah, output 0. So when I go to spend that, that is now this token's ID. And this, just like the origins we talked about at the inscription level, this token ID will follow this token everywhere. And every time you spend it, you have to include this token ID with your transfer inscription. So if you make a transaction where you put all these things as an inputs, and your outputs don't allocate for all these coins, or don't allocate for these coins at all, well, you just destroyed the tokens that you just created. I might actually need to grab a water here. Pardon me 1 second. I've got some sitting at my table. Maybe. So, what BSV21s, or the V2 of BSV20, really, kind of what its secret sauce is being able to deploy an entire set of tokens in the same transaction where those tokens are owned by an sCrypt contract. And so in this case, these tokens never existed owned by a person at all. In the same transaction they were created, where this deploy got inscribed, they are owned by a contract immediately. And so block to mint that we came up with is very much about, this is an sCrypt contract that knows how many tokens have been created with it. It knows how many tokens it controls. There's some other configuration options that are passed in here. Like, so in this contract, you are locking up Bitcoin. So essentially, if you want to mint some of these tokens, like Bamboo was the first one, I think you had to lock up. I think you had to lock up your tokens for a year, or your BSV for a year. So you lock up your BSV for a year, and there's some equivalation, but basically for however many BSV you lock up, you get that many Bamboo tokens. And so what the contract actually enforces here, okay, how are we locking for? So this multiplier is about how many Satoshis versus how many of the tokens are you getting. Last height, that's kind of just some, I'm going to skip over that unless there's specific questions about that. But, so as soon as this is deployed, the entire token supply is owned by this contract. And at that point, anybody who wants to can call this redeem method. So redeem method, they pass in who's going to get the lock to mint tokens. The Bamboo was the first one. No, sorry, this is what address is locking up coins. This is who's going to get the reward, and how much are they locking. And what the contract essentially does here is it does the math, it figures out, okay, how long do I need to lock these up for? And then it builds the output to the transaction. Oh, I didn't include that slide. Oh well. So it builds the lock output. So this is basically saying, okay, there's this lock contract that locks up coins for a certain amount of blocks. So we got to build an output that's got coins locked up. We have to build an output that transfers some of the BSV21s that this contract's holding on to the recipient. And then we have to, up top, we also have to keep track of our own supply, and if there's supply left in the contract needs to kind of get restated so that someone else can call this again and spit out more coins. So this sCrypt contract is enforcing everything about the distribution model of these tokens. And these tokens, they came into existence when this contract came to existence, and every time this contract's called, it's going to spit out new tokens until it's out of tokens, and then it's going to stop existing. Any questions on that? Yeah.
Yeah, so, is it up?
There's a mute button.
Hello?
Hello.
Okay, good. Yeah, just a question regarding this. So when you guys start, let's say, minting or issuing, whatever you call it, this Bamboo, do you have any concurrency issue? Basically meaning,
yes.
Because it's a single UTXO, so it's kind of like a back to the account model again?
It's not back to the account model, but it does have the downfalls of, yes, in this approach right here, the fact of the matter, so, I don't know good way to put it. But anyway, there's an output, and anybody can call it. And so the first person who calls it is able to spend it, and the contract will restate itself, but there's no way for you to easily know where is this contract, or what transaction was this spent in. And so we do have quite a bit of an indexing process, and especially this has been pushed with the POW20 stuff, where there's a lot of people competing to spend each out point. And there can be these times of lack of visibility where someone is spending it and spending it and spending it and chaining transactions together, and everyone else is kind of like, I don't quite know what the state of this thing is. So there's definitely some issues there. Now those can actually be solved fairly easily. In fact, the next thing I'm going to get into will show a concept of a contract forking. So you could certainly do it in such a way where the entire supply gets tied into this contract, and the first time you call it, it splits half of itself into two different restatings of the contract, and then gives the reward and then the lock, and then every time you call it, it just kind of fractally forks out into new out points. There's some other challenges there of then being able to find what are the valid out points. There's a lot of kind of indexing and searching that needs to go into all these different solutions of how you spend these transactions, because things don't really become public until they end up in a block. And things don't necessarily, I should say, become public until they end up in a block. And so if you've got things where the incentive, the economic model is very quick, do it now based. So I mentioned, for instance, the POW20 stuff. You've got those races at easy difficulty levels. But when you have real hard difficulty levels, and it's going to take someone 5 minutes or 10 minutes of mining to find the next solution, well, this whole race aspect becomes far less of an issue. Because you've got a lot more work to do. And so therefore, as things slow down, it actually kind of evens the playing field a fair amount.
Cool. Do we have a sense on how many concurrent users in general for the current blockchain, like 100, 1,000, when a lot of people start to see, let's say, get the stale, let's say, chain tip type of issue? Because
the lock to mint stuff was actually fairly new. There was definitely contention and there was definitely issues, but it was kind of like it was the first of this kind of thing, and so it was kind of just part of a fun little, yeah, you're racing against people to get yours, and sometimes they beat you to it, and it's just kind of a fun part of it. But as far as like a mass, high quality platform, the user experience is not there. Specifically about the use though, like when it comes to POW 20, I mean, over the last couple of weeks, it has certainly been slamming the server. I mean, there's a lot of people interested in getting the kind of the chain tip of it as quickly as possible to be able to mine on it. And that's going to have some of its own kind of unique solutions that need to be proposed of how to solve that. But certainly, like your original question asked, the fact of there being one output and everything being tied in one output certainly proposes or raises some pretty significant issues as far as how do you resolve that? Okay.
It's too excited about the talk.
All right, so then I've got one more kind of. Oh, come on up. I mean, I pretty much have one more thing, and then it's going to just turn into an entire question and answer session. So, but you can ask right now. I'm happy to hear.
Please come up here. Yeah, everybody with questions, please come up to the front, and then we can get the mics getting close enough.
You're unmuted.
I'm unmuted.
You're unmuted.
Okay, good. Yes, thank you. You may have already covered this, but if you could repeat it for me, that would be very kind of you. So I'm wondering, what is the input of this contract that gives it value? Things need value. Okay. For example, it's like when I purchase Bitcoin, the value I input is US dollars, which have value because I put labor in to create those paper dollars or those digits. So with this, what is the input that gives it value? The output.
Yeah.
Right. Thank you.
Yeah, absolutely. So from my standpoint, for pretty much everything that's out there right now, there is no value, and that's not the point. And I make no claims of there being any value on anything, and I mostly make fun of people who do value this stuff. But if people want, I mean, in both, like the two we've been talking about of the lock to mint and also the POW 20, there is a demonstrated opportunity cost that is put into the contract in order to produce the output. So in the case of lock to mint, you are locking up Bitcoins such that you can't get them for a period of time. Whether that's got any value, I don't know. That's not my call. I'm playing with software. Same thing with POW 20. I mean, people are burning electricity in order to solve hashes in order to earn these coins. Is that valuable? I don't know. But
it's time and energy.
Yeah.
The baseline.
It's the energy.
The baseline value is time and energy.
Right. You have to have some kind of energy input.
Absolutely.
And electricity.
Or time, or if you lock. When locking in is mining, you can do lock-in mining. But if you get this token, you've given up energy, or you've given up the opportunity cost is a good word when you lock the coin for 1 year. So that's the floor value.
It's like you can just summarize that when you're done.
Yeah.
And now that can be, a little ambiguous, but it's a kilowatt per
Still,
hour,
it's
and
still,
$500 I've locked in for 1 year. I don't spend it on, gold or whatever.
So to restate.
So it's still energy of some type, labor and then electricity.
It's like energy and time.
All right, I'm gonna keep going, and we can break into that later. So essentially, just to summarize the conversation here of just stating there is costs in both a proof of work to mint or a lock to mint of people are giving up something, and whether that is value is completely in the eye of the beholder. All right, so the one last concept I want to talk through here, and then it's going to just be open up for any questions anyone's got. Oh, it looks like. So this is OpNS. So I rolled this out, I don't know, sometime last year. And the idea here is this is a globally unique domain name registration system. It doesn't have to be domain names, but essentially a way to earn a unique thing that is provably yours and provably unique. And so OpenS, this is going to get a little convoluted, and I also see that I've got some rogue lines that I don't know where those came from. But essentially, there is a contract that I deployed, I don't know, let's say May, June last year sometime. That was the Genesis OpenS contract. So that contract represents the ownership of the name empty. There's nothing there yet. It's an empty thing, and the array of what has already been claimed is an empty array. So this is just a fresh state. There's nothing that's happened yet. And so the idea on OpenS is basically to hierarchically track one letter at a time who owns different, basically to do a string building of mining one character at a time to build a string of a name that you own. And these are proof of work mined, not quite as advanced as what POW20 is doing. It's very rudimentary proof of work, but that helps just kind of make it so that, well, actually going back to the racing of spending the outputs, like putting in a little bit of friction actually really helps the performance of the system at all. That if someone wants to do it, they do the proof of work. It's far less likely that at that moment they're going to be racing with someone else who did the same proof of work to get the same solution back. So at its first state, OpenS existed essentially as one output that had no state. And so this is kind of going through, if I were to mint Sugar, which is kind of my name that I've got. So the first step here is from the empty domain, I need to mine the S. So nothing is claimed at all at this point. S is available. Everything's available. I do the proof of work to mine S. So when I submit that proof of work to the contract, it spits out three different things. It spits out the same contract again with an empty domain saying S has already been claimed. It spits out another one that represents the S domain with nothing having been claimed. And then it spits me out my ordinal that is my S. I own the letter S. But now we have two outputs of the contract. So when we talk about these kind of racing to spend the newest out point, well, there isn't one newest out point. There's two newest out points now. And as I continue to go, that's going to keep splitting. So my next step is to go off of the S domain and to mine SH. So I want to get the SH off of S. So I do that, I do the proof of work, I call that contract. That's going to spit out new contracts. If here's the S, H has already been claimed. Here's the SH with nothing claimed, and here's my SH that I own. Third step, so I need to get the R. So same concept again, I do that, it spits out an SH with R claimed, it spits out SHR with nothing claimed. And then I wanted to show here is this other one of someone wanted to, some word that starts with SHI, Shiv maybe. If they wanted to do that, well, they actually have to spend the output of this SH. So they're going to spend that, they're going to mine the I. So SH is going to get restated with the R and the I already claimed, and then SHI comes out with nothing claimed, and then that person owns SHI. So it's this hierarchical way of using an sCrypt contract and proof of work and one Genesis pointer online that there is published on, I don't have the OpenS website somewhere, but there is a published, this is the Genesis transaction. And every OpenS that will ever exist will trace back to that Genesis transaction, or else it's a counterfeit. And so it's real easy to actually validate by simply at the point where I own this, I own a transaction as this ordinal in an output. I can literally walk back the transaction chain of that ordinal, look at the previous transaction and all the way out, and if it leads back to that Genesis transaction, it's a legitimate OpenS that I own. So contract for this, I'm probably just going to skip over this briefly, but so we got a concept of top-level domains. That actually isn't really implemented in this because everything we're doing is at the empty, but you could do hierarchical domains with this as well. I've got a difficulty that's just fixed. Again, I don't know that there's a whole lot to go through on this. When you actually do the minting process, So you are passing in the character you want to mine, the nonce which solved the proof of work for that character in this transaction, and then trailing outputs. And I want to actually touch on that a little bit in just a second. This is a pattern I've been starting to use a lot in my transactions, because in my contracts, because it really opens up the door for what you can do with them. We'll get back to that. So essentially, someone calls it, we validate their proof of work is valid, we validate that the character hasn't been claimed yet, we update the contract with this claimed and POW, we restate the contract out, then I clear out the claim to spit out the second contract that has the domain updated, and we spit out the actual ordinal itself, and we spit out trailing outputs. So this is I'm pretty much done with op-ins until there's questions, but I did want to just touch on this trailing outputs concept. So within the sCrypt tooling, they have this concept of a change output. So your contract builds its outputs, and there's this very convenient, just built-in function to say build change output, and it'll just figure out what it needs to do to spit change or not. That's great if you're just doing one thing and one thing only with these transactions. But by throwing this trailing outputs in here, and now I'm actually in this one not using the change output, but I have started using that a lot more. So if you actually are validating all the outputs that the contract cares about, but you allow the user to pass in another array of non-change outputs, then you can do lots and lots more things with these transactions. So you can build up external atomic swaps where someone, if you fulfill this contract for someone or you submit this transaction for someone, other contracts can be executed or implemented in that same atomic transaction. Or secondarily, if you wanted to... It wants me to charge. Alternatively, if you're wanting to charge a... So let's... When we were... So IAM was the company I was working with when we built this. And when you would mine these op-ins domains through their website, they would take a fee. And that fee output just got stuck in this trailing output. So when you call the transaction and you're saying, I want there to be a mining fee that this website is assessing, they can really easily throw that fee into the same transaction atomically. And essentially, this transaction can mine these op-ins domains, but can also create any other outputs you want to and any other logic you want to in it. So that's kind of all I've got thrown together, and I'm open for questions and answers as much as anyone wants to ask.
Yeah, stronger. Can you use dark mode next time so we can see easier?
I'm going to try and maybe if someone else makes my slides for me and not me doing it on an airplane like this.
Fair enough. Hey, Jamie, do you think that... Also, you can watch the live stream.
So do you think that this is like the NFT protocol of Bitcoin?
I think Ordinals itself definitely is, because why we can do all these complex scripts with these is because literally we're locking up a Satoshi. And it's just like locking up, just like the LULOC contract where you're locking up a lot of Satoshis for some period of time. It's that, but it's just a single Satoshi. And so whatever script you want to apply to that Satoshi, as long as how you're building your contract, it ordinally transfers such that if it's input 0, it comes out, what you want to have come out comes out output 0. Well then, yeah, I think that, I mean, Ordinals has exploded very logically because it's kind of this thing you get for free in Bitcoin if you look at Bitcoin in a certain way and you don't have to do anything else and all the script works. Now once at Ordinals, coincidentally actually, there's been some controversy on BTC because a new mining pool started mining. So they actually have to do, you're inscribing a dust output, which is 546 Satoshis, I think is the minimum, and only the first Satoshi in that gets the inscription. So there's a lot of like more complicated rules that BSV just supports one Satoshis. And so all that complicatedness of, okay, I'm trying to do ordinal-based things on a whole blob of Satoshis, we don't really have to worry with on the BSV side. So, I mean, I don't know. I think ordinals are definitely, it's just a native thing of Bitcoin that gives you NFT functionality, and I think that probably will be the future of NFTs.
Awesome, thank you.
Hey, David, should this trailing outputs be built into sCrypt? Is this a pattern that you think, like, kind of, I was thinking about like composability. You talked about calling other contracts from within these trailing outputs. So like, what do you think about that?
I mean, there's a lot of, whether it should be built in or not, that's an interesting question, because like the change outputs that they've currently got, that only comes into existence if you use it in your code. And if you're not using it in your code, it compiles an entirely different kind of contract that doesn't need any of the complexity. So when you've got the context in sCrypt that involves that you're going to be building an output TX transaction, which is an entirely different kind of transaction, far more complex. Like, I don't know if it's a pattern that fits for everything, but I do think it's a pattern that's really easy to add for developers where your contract needs it. And it really costs you almost nothing as far as code standpoint or size to be able to support it.
Hey, I just want to circle back on the concurrency side of things.
Yeah.
When you're... Hello? Is on? Oh, okay. Yeah, I just want to circle back on the concurrency side of things. I can think about two ways. You know, V2 is one way. Let's say you are, say total supply is let's say 21 million, right? I can either, when I first deploy, I can split to let's say 21 UTXO, each one containing 1 million, and then every single one is like one, let's say account, and then you can have like concurrency of up to 10, right?
Yeah.
So that's one way. The other way is, but this is not enforced. For the first split, it's not enforced in contract. The other way I think you are hinting at, to me, is like you put in a single UTXO, and then every time you are like a tree branching out, enforced by the contract itself. Do you see any, I don't know, any, can you compare this two? Do you see what I mean?
Yeah. I
really want to use that whiteboard if I want.
Oh yeah. Yeah, absolutely.
Yeah.
We'll capture it on stream too.
I mean, we spend like a few $100, so it would be just for the sake of it. We want to use it just at least once. So, can you see this?
Getting there. Hang on. All right.
Yeah, the first thing I can think, visually, you know, is let's say that's one UTXO, and then you first split into 10. Let's say 5. Okay. Just. And then every single one is like that you can keep meeting, everybody race to, but then you at least have 5 concurrently, at least 5 people are less. It's less contentious if you only have one. The other one is, I think what you are talking about is like, it's almost like a tree. Every time you meet, you can optionally.
Well, it doesn't even have to be every time too. Like you can every 10th time split. Or
yeah, something like that. Yeah. Or maybe like. Do you see any? For me, the difference in the first one. This is not, I mean, you can put in the contract, but this is going to be potentially big. So this one is, I think it's more lightweight. So when you deploy, you also split it up.
Yeah, I mean,
so people can check first. Hey, it's really what it says. It's not in contract, but I can see the transactions.
Yeah, and in the case of BSV 21s, like kind of the whole thought process around the concept was essentially, here is also where the actual tokens themselves exist, is in this deploy, where in this case, you have to kind of deploy the tokens. Someone is deploying these tokens and then splitting them into a bunch of different outputs. So kind of the thought process being worked through is how can this all be in one atomic step that the token gets deployed and the contract owns them, and there is nothing between those two things. Now, I think there's probably ways that you could actually deploy them into a contract that just splits itself one times into a bunch of these. Like, I think you could certainly work out ways to merge these two models fairly easily, but yeah.
Yeah, so in this sense, you can always, even though you are using V2, but you also mimicking kind of the Yiqiang one.
Yeah.
Because you can, depending on how viral the OBJK goes, you can put in 100 or, I don't know, 2.
Yeah. Well, and the fact of the matter is, if the Teranode future comes in the short, like, the concept of publicly spendable tokens where people can just find the head, and like that's got its own scalability risks, which I'm sure Kyle will probably talk about tomorrow or later today. But like, yeah, so you end up getting to the point where sometimes you might actually need to put some consensus rules into the contract spends itself, just that forces something that slows it down, that makes sure that people who are involved in this process know that this transaction spend happens. Because if I've got to search through the next block of 43 trillion transactions to find where this one got spent, that doesn't work. And so you can certainly build more and more complexity into the contract layer that says, okay, maybe there's, whether it's simple as like a proof of authority that says, okay, I need a signature from one of these consortium members, or whether it's a full proof of stake contract built in there, or what, like, I'm not going to, technologically speaking, you can put all sorts of logic in these contracts that means in order to spend it, I have to get a signature or a sign-off process from someone who needs to, or who has now seen that contract so that they know about the spend and they know about the state, and yeah.
So what do you think is more suitable or preferable to track this? Because is it the app layer, or is it, let's say, Astra would offer some kind of services? Do you have a sense of that?
I think it totally depends on how technologically you solve it. Like, on a, certainly you can throw certainly, there's nothing certain about any of this. Like, it's not an easy solution. It's either you get to a trustworthy bridge that says, okay, here's where I get the state, and here's the mechanism, the signature I need to get to update the state, in which case it's a purely permissioned system. Or you've got just kind of the free-for-all that says, I can spend this UTXO, and if someone else can find where I spent it, they can spend the next one. And it's just that's part of the economics of the whole system that says you got to be able to find where the head of the contract spends are, this contract chain. And if you can spend it. If you can't, sorry. And I think that, the work I'm doing with JungleBus and with one-side Ordinals indexer, I'm definitely trying to offer solutions to say, okay, here, how do we find the newest state of this? And the closer we can get to the JungleBus level, where it's like, okay, this is the miners, as they're just doing their validation of everything, if I can just tag transactions and note them such that it's obvious that we need to follow this chain of spends, that helps solve it too. But I don't know if there's any one solution. I think it's going to be, there's going to be lots of different solutions for lots of things you're trying to do.
I just want to pass it off.
Any questions for David?
Going back to the locking, currently how it works is you have to manually go claim after the unlock period, after a block height or whatever.
Wait, which lock are we talking? Oh, yeah.
Lock to mint.
Yeah.
So can you talk a little bit about how that claim works and what can happen to have that automated? I think that's kind of now that lock to mint has become relatively popular.
Yeah.
In this context, it's how do we get to the next step?
So there's also some questions about some of the difficulty lock stuff that Jack's been talking about recently that ties into that same thing. And really what you need to get to, there's kind of at the unlock step, there's one of, I guess first of all, let me say this. Somebody has to call it. There's no automated thing that's just going to magically interact with Bitcoin in the future on your behalf. But it all depends on so in the case of the current locking contract, the LULOC contract, all you're really doing, all that's really built into the contract is something that says, I've proven that this height has been reached, and here is the signature, here's my signature saying I can unlock it. So it's just like any other spend, but it has a lock height, a lock time stipulation on it. Well, if you write the contract differently, where when you lock, it is stipulated who gets to be the recipient of it, then at that point, anyone can submit a proof that says, okay, here's proof that the chain has reached this point, but the contract's only going to allow it to be spent if that beneficiary gets paid out that amount. So if you take off the concept that says, I need a signature from someone at that unlock step, and you move that signature to the kind of commit step, such that on the unlock step, all you got to do is prove the terms of the contract, essentially, and a predetermined person is going to get paid out, then at that point in time, anyone can unlock it. And so you can have an automatic service that's just looking at, okay, what unlocks do I need to clear up?
Real quick, could it unlock into our lock contract by default that then has...
Yes. I wish I would have... I didn't actually put the code here of the... let's see what I get. So this build lockup output code here, what that essentially does is it has got the compiled code, the actual binary code of the lockup contract, which is the LULOC contract, and it literally is building script on the fly to create a kind of a it's a pre-compiled, let's stick together a string to make this be a valid contract. But you can do that with any number of other contracts. But, like in that case, the lockup contract, its code is part of the lock to mint contract. And so when it creates the lock, it's actually kind of creating an output that has this binary data with this variable stuck here and this variable stuck here.
So in every event, just for prosperity, in every event, the unlock happens, there's a claim, that's a transaction that somebody's going to pay for at 1 sat or whatever, even though it's nearly zero.
Yeah.
There's another transaction, so like, a service could pay to automate it back into the user wallet to be used again.
Right.
Or the user could pay, or...
Well, the other concept of the automatic locking is simply that could just be part of the things that your wallet knows how to spend. And so literally it's just like any other UTXOs you've got that can be spent, but you can't do it until you've reached that maturity stage.
That's a good point, yeah.
So if the wallet has that logic, then it's seamless. There is no unlocking to be done. You're just spending it.
Yeah, we like that.
Yeah. All right. Good to know. Anyone else? Oh. Okay.
I think locking would be really interesting for NFTs as well, especially with the popularity of NFTs, ordinals on BTC.
Yeah.
Because project founders will want to reward people who purchase their NFTs and then lock them up for X amount of time.
Yeah.
Is that something that is possible?
Yeah. You can lock up an ordinal output in the current lockup contract. You can actually even mint in a new lockup contract.
But for BTC.
Oh. I should have known that's where you're going. I don't like BTC supports the concept that says I'm going to lock stuff up, but that's it. Like you can't put any really other logic, and I don't know if you could inscribe in that. I'd have to look into that more, but
you can lock and unlock.
You can unlock and unlock. Well, you can make it so UTXO is not spendable until a certain date. By using, that's essentially how Lightning works. Is the whole idea that says this UTXO is encumbered. The locking script says check lock time verify needs to be whatever, so you can't unlock it before this height. And yeah, you can enforce it that way. But anything else you're doing in there isn't going to be in any sort of sCrypt contract. You got to have your own logic, your own second layer of making sense of all that.
I think it could be really interesting as far as like an inception method, or it would be very popular on BTC. Just saying.
So I have a question coming from a whole different point of view. So in the late 80s, I sold software systems on minis and mainframes to solve business solutions that people were doing it manually. So I'm constantly thinking in the business world. And so now a lot of people use computers, but they don't necessarily have it in the cloud. So how do we use this whole ability with Satoshis and transactions to get into the companies, to have all their transactions of their, like, I used to go in and interview everyone in the company to see exactly what they did, so how I was going to automate that when it got around to putting the computer in. Because if you sped up what they were doing manually, but their manual procedures weren't good, you really ran into a problem. So I went in to find out exactly what they were tracking, how they were tracking it, so that when we put it on the computer, it just seamlessly went through. Like, let's say they were tracking trucks, and they had like 6 or 8 different things they had to track: the truck number, the driver, the time in, the time out, things like that. So my question to you is, how do we go to businesses and take this idea of these transactions and go online with it, as opposed to making ordinals that, like you said, what value do they have in the real world? So that's
that's a great question, but it's a question that I'm making no attempt to try and answer any of this. That's kind of like, you can do lots and lots of stuff, and I would love for people to say, here's what we need to do, how do we do this? And then there's
so
an answer
if
for
I bring
Xiaohui
a company,
myself.
if I bring a company to you, and I've already interviewed all the different people, and these are the transactions we need to track, we can write smart contracts to do that, so the company can go from being, let's say, like my company that just has an online server, or a server that we just track all our data, all our transactions, everything that happens. We can put all that in a smart contract, and then that can be in the cloud, and then all these reports can be printed out for these companies. So that's doable?
I mean, it's probably doable, but I'm not going to say that there's a, like, I don't know how templatable it is. Like, I feel like a lot of this stuff at this point is, there's not going to be a...
I think it's going to be company by company. Yeah, you're going to have to go in and find out what the company does. Okay, got you. That's what I thought. Thank you.
For now.
Yeah.
So, can you put the different, like, I don't understand this all too well, but because he was asking about how do you track a truck or whatever, but can you have, instead of just the image or whatever, like there's certain data fields where it's like, you know, the truck driver, the truck name. And
Yeah, and really, so how I'm looking at all this stuff is so just like Xiaohui is talking about kind of the tool base, and you've got this sCrypt thing in the middle that's like part of the tool chain. Well, a lot of how I'm really trying to look at these things is all just very much small tools that are in different layers. So for instance, the BSV20 fungible tokens are not really related to ordinals at all, except for they use ordinals to embed to inscribe their payload, which then a BSV20 index or a BSV20 rules are applied to how that all works. So it's like everything is like at the very basic level is the ordinal concept. And then on top of that, there's this concept of inscription, where it's like on this trackable history of this one Satoshi, I can put stuff on it.
Okay.
And then the next layer is the stuff I put on it complies with this protocol, and so I can interpret it this way. And I can wrap it up in a contract that knows how to deal with all three of those layers to make sure that what comes out is compliant with what you want it to do.
Okay, so like that makes sense. So like with the inscription part, like Craig always talked about bills of lading, where it's like there's a ship coming into the port, it has a bunch of, you know, goods, and whoever owns that piece of paper gets those goods, and people are trading it on the, you know, at the dock. And so that could technically be inscribed into one of these.
Probably, but I don't think it's going to be that simple. I think it's going to be more like maybe the assets themselves are inscribed and tokenized, and then those assets all get bundled up in a shipment container tokenization. And so as that transfers, that like I don't think it's going to be a simple like, oh, I just have an ordinal and I just do it. Like you still have to build out kind of modeling the business process in the code, in the chain, in what you want to accomplish to pull this stuff off.
Okay.
Funny story about that though.
Yeah.
London Blockchain Conference last year, I was very much not kind of watching a whole lot of the presentations. I decided to go watch the Craig presentation, He was talking about bills of like I took 4 steps in. I heard the word bills of lading, and I left because I was bored.
Well, that's like those are the things I want to use this stuff for. I don't care about the, the whole. I want to build a market. I want to make the fruit industry more efficient. And right now I'm at wholesale markets, and it's all just it's good, it works, but it's not 21st century. So.
Yeah.
So yeah, I don't understand it enough, but I think that if this is the NFT protocol, and an NFT is a non-fungible token like a stock certificate or a bill of lading or whatever, I'm just understanding how this fits into that.
Yeah, I mean, essentially, I think what it really boils down to is anything you want to tokenize lives on a Satoshi. And that Satoshi represents that, and all the other things are different layers, interpretations, and protocols to be built on it, but essentially, you have a Satoshi is ownable, it's trackable throughout its chain immutably, like that is the atomic unit of Bitcoin, and by us being able to stick a serial number on those things, we can use just the atomic properties of Bitcoin to represent anything.
Right, that's non-fungible.
Yeah.
Cool, thank you.
So coming back to what we were talking about earlier, let's say, for example, I have a company and we go from property to people. So we represent lots of properties. And on any specific property, we put a control number on it so it's easy to identify. And then we might do multiple years where we're appealing values. We might have multiple assessors we work with, all kinds of data. So we need a controlling number, right? And then, so let's say 1 Satoshi. Then can you go from that 1 Satoshi and branch it off all over the place like on a Merkle tree so that it does all of this stuff that's associated with that one property?
Yes, but it's also very possible that, again, just like I was saying a second ago with the bill of lading, where that Satoshi, yes, that might represent the property.
Yeah.
And maybe it goes into a contract where everything that's dealing with that property is spent in a transaction where whatever new information is also being added.
And so you would need to have a whole bunch more Satoshis that would be associated with that?
Well, potentially. Basically what you're doing is when you're creating a transaction where all of these tokenized things are inputs, so that's showing that the person who owns the thing is signing off on whatever's happening in this transaction.
Right.
And so then maybe that transaction records some more data on that thing or on something else, whatever. So like the fact that all the different assets that are coming input have had signatures that owner is attesting to what is happening in this transaction. And then the outputs can be that everything just goes back to the same person. Like nothing has to change hands in this transaction at all.
Right, it's just tracking it all, and so you could actually do all the accounting, all the history, everything
it's
could all be
packaging up into one atomic unit of this all happened and all these people signed off on it.
And all you need is a bunch of Satoshis then to just kind of keep it rolling.
Yep.
Yeah, that's cool. Okay, thanks.
Anything else, or we got lunchtime?
All right. So thank you very much, David Case. That was a really great talk. And this is really just the beginning. We have 3,000 people watching on CoinGeek Twitter right now, guys. We got another day and a half of this coming up. We got Babbage speaking. We have so the next one, we're going to come back at 1 p.m. There's going to be a presentation talking about the sCrypt Ordinals SDK. At 2 p.m., Babbage is going to come up. We got some later today. And then tomorrow, we got Thomas Giacomo from the BA. We have Jake Jones of Teranode. The million TPS guy, that guy. So come back at 1 for the presentations after lunch. And then tomorrow, it's going to start up again at 9 a.m. And we'll get back to it. So thank you guys very much.
Here's